Hi, this is Mrs. Curl, and I am going to take you through our first lesson, which is going to be on simplifying rational expressions. So as you can see, we have just a little bit of a warm-up here, and I'd ask you to pause this video and see if you can't figure out how to evaluate each of these expressions. Okay, so hopefully you've given it a try and you're back with me. So if you have an expression like this, what's really neat is that each one of these numbers is called factors, and it's because they're being multiplied to each other. And when you have the same thing being multiplied in the numerator and in the denominator, they cancel themselves out. So for example, since we have this 5 as a factor and this 5 as a factor, we can cancel those out. And we can keep going with that. We have a 4 and a 4, a 3 and a 3, a 2 and a 2, and a 1 and a 1. So really all we're left with is 7 times 6, which is 42. See? Didn't even need a calculator for that one. Same thing on the bottom. We can start here with 998 and 998 on the bottom. And then everything below that would cancel out. Everything above cancels out because we have the same thing in the numerator and the denominator, which simply leaves me with 1,000 times 999, which would be 9,999,000. Okay, so the big thing about today's lesson is that whenever you have a factor that's the same in the numerator as it is in the denominator, it can cancel itself out. Therefore, here is the title of today's lesson, Simplifying Rational Expressions. Here's a note that I'd like you to copy. You can pause the video right here to take some time to copy this note. It simply states that polynomial expressions that can be simplified to the same expression are what we consider equivalent. Rational expressions are quotients of two polynomials. All that means is that you're going to have a fraction, you're going to have some kind of polynomial in the numerator, and a polynomial in the denominator. With rational expressions, we must remember that the division by zero is undefined. So if you remember, when we have fractions, we can't have zero in the denominator. So we have to consider these restrictions when we're simplifying. So let's get to simplifying. So the following expressions are considered to be equivalent. You notice this is our factored form. And this is our standard form. But if I was to graph these, I would get the exact same graph because they are equivalent. The following can also be said if you take a look at this expression that I have in the bottom. Notice I have an x plus 10. So this is what we consider a factor, the whole binomial. And this is also a factor. And because you have the same factor in the numerator and in the denominator, they can cancel themselves out, which is why we have that equal to x minus 9. Okay, so when we simplify it, we end up with the same thing. The only difference with this is that I have to talk about my restrictions. And my restrictions are what x is not allowed to be. In this case, x would not allowed to be negative 10, because if I put a negative 10 into my denominator, I would get negative 10 plus 10, which would give me 0. And remember, you can never have 0 in the denominator of a fraction. Okay, so just a little bit of a review on how to reduce fractions to lowest terms. Remember, we're looking for the largest number that will divide evenly into the numerator and the denominator. In this case, 4 can divide into the numerator and into the denominator. So that simplifies to 2 over 1, or simply 2. Over here, the largest number that divides into 35 and 10 would be 5, which would give me 7 over 2. And over here, the largest number that divides into 4 and 12 is 4, so that would give me 1 over 3. So when we're simplifying fractions or rational expressions, we can also simplify some coefficients. And therefore, we're looking for largest numbers that would divide evenly into numerator and denominator. So let's get started on simplifying some polynomial expressions. Okay, so here we have 2x minus 3 over 4x minus 6. We want to simplify this and state any of our restrictions. Now, one of the big errors that students make is they want to just start going ahead and canceling out numbers and putting like this as 1 over 2 and this as 1 over 2, and then these x's can go, and that is not correct. Okay, each one of these are considered to be a term by themselves. So this is a term, and 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 therefore we cannot cancel out terms. You're not allowed to cancel terms. You're only allowed to cancel out factors. And so the first thing that we're going to want to do then, since we can only cancel out factors, is we want to factor this. So you always are looking to factor as your first step. And so 2x minus 3, there's nothing I can factor there, so let's leave it as 2x minus 3. But on the bottom, I can take out a 2, which then leaves me with 2x minus 3 inside my brackets. And now, if we look at this as a whole factor, this is a factor, and this is a factor. Then it can cancel out. So we can go ahead and cancel, leaving me with just 1/2. Again, we have to talk about restrictions. Now in this case, we're going to take what our factor is. Anything that has an x in it is going to end up being a restriction. So in this case, we have 2x minus 3. To figure out your restriction, take that and put it equal to 0. And then solve for x. So 2x equals positive 3. Divide by 2, x equals 3 over 2. And then we just put a line through our equal sign to show that it can't equal that, because if it does equal 3 over 2, then we'll end up with 0 in the denominator. Okay, let's try another one. What if we had x squared plus 3x minus 18 all over x minus 3? So again, remember, our first step is always to factor. Very important. So I'm looking for two numbers that multiply to negative 18, but add together give me positive 3. And those two numbers are going to be a positive 6 and a negative 3. Notice now this x minus 3 and this x minus 3 can cancel, leaving me with x plus 6. Of course, we always have to talk about our restrictions. So I'm going to take my denominator, x minus 3, and put it equal to 0. And that tells me that x can't equal a positive 3, because 3 minus 3 equals 0. Just to let you know, if you were going to go ahead and graph this, the graph would look like the line x plus 6, except that it would have this hole in it. And that's literally what we call it. We call it a hole. Right here at x equals 3, you can see we have this hole. And the hole is because that's where our restriction is. So we can't actually have a value there. It's kind of neat. We're not going to worry about the graphing of this, though, but I just want you to realize that's what would happen if you actually went ahead to graph it. That's what the restrictions do. They can cause holes in your actual graph. Okay, so here we have another one. Again, first step, always to factor. So let's take a look at that numerator. Two numbers that multiply to negative 10 but add together give me 3 are going to be x plus 5. X minus 2, and then in the bottom, two numbers that multiply to 15 are going to be x plus 5 and x plus 3. We can see that the x plus 5s are the same, so they can cancel out, leaving me with x minus 2 and x plus 3. Those are considered factors, each one of those, so we cannot cancel them out. They are not the same. So please do not go ahead and try to cancel out those x's. You are not allowed. But we can talk about restrictions. So our restrictions, there's actually two of them. The x plus 5 equals 0 means that x can't equal negative 5. And the x plus 3 equals 0 means that x can't equal negative 3. And the reason being is because if either one of these binomials that are on the bottom, if either one of those sets of brackets equaled out to 0, then it would be 0 being multiplied by the other set of brackets that also equals 0. So we have to look at each one of those cases, and we end up with more than one restriction. So in this case, two restrictions: x can equal negative 5 and x can equal negative 3. All right, here's another one. And again, I'm going to start with factoring. I see that this is cubic, which tells me then it's not my quadratic that I'm used to. So to factor this, I'm looking to see like common terms. So I see 24, 6, and 12, which means I can common factor out a 6. And x cubed, x squared, and x means I can take out an x, leaving me with the inside of 4x squared plus x plus 2. And then in the bottom, I have 6x. And now I have a 6x. This is considered a factor. This is considered a factor. They can cancel out, leaving me with 4x squared plus x plus 2. Okay, my restrictions. I'm going to take that 6x. I'm going to put it equal to 0. Divide by 6, divide by 6. So x can't equal 0 because 6 times 0 would give me 0 in the bottom. Okay. So there, that one wasn't too bad. Let's move right along. Same thing, what if it looked like this? So this time, we're still starting. We're still going to factor first. So we have x in the bottom. And I can take a 2x out of the denominator, leaving me with an x minus 2. Okay, so in this case, because x is all by itself, this is considered to be a factor, but only because it's all by itself like that. And this is considered a factor down here, and since it's being multiplied, we can take this x out of this x, leaving me with a 1 in my numerator, a 2, and an x minus 2. All right. So let's talk about these x's. Well, I have this x right here, or 2x. I can put that equal to 0. Divide by 2, divide by 2. So x cannot equal 0. And then I have this x minus 2 equals 0, which means x can't equal a positive 2. There. And those are my restrictions for that question. Okay. So that's it. I'd like you to go to page 83, and I've included the PDF in this email of that page, just in case you didn't take your textbook home, 3 to 6, 11, and 15. And please feel free to email me with any questions that you might have. I'd love to help you out. Thanks.